On the shark bite, which numbers do we want to see, do, go over, have questions about? Five. Okay. Any others? Five is good because it kind of refreshes our memory of domain and range. Well, in this case, just domain from way before we went on break. So domain, we're looking at furthest point to the left, furthest point to the right. This has endpoints or walls. So we're looking from one endpoint to the next, reading left to right. So you could write that in set notation or interval notation, either or. I'm going to write both. Set notation would be between -3 and 1 with the less than or equal to's because they're both closed endpoints. And then interval notation would both be with brackets since they're both closed endpoints. Questions on that one? Any other questions on the shark bite before we move on? Before we start our notes, I'm going to talk a little bit about, just to refresh our memories. I know we probably haven't thought or talked about transformations since before break, but prior to that, or prior to break, we were talking about domain and range, increasing and decreasing, and constant intervals, where those happen. And then we talked about different transformations, horizontal shifts, vertical vertical reflections, horizontal reflections, vertical stretches and compressions, and how that affects the graph, how it moves, flips, gets wider, gets narrower, all those things. Today we're going to use those transformations with graphs. So everyone should have these graphs, this paper in front of them. And we're going to be looking at these graphs to see what transformations happen compared to the original, the parent function, and use those transformations to write the equation. So before we were kind of given that. So it may help if you take out the last set of notes on transformations. That way you kind of have that to compare back to, because it's been a while since we did transformations. So you can take that out. If you don't have that with you, that's okay, because we are going to be talking about it as well. So we're given some function, and we have to figure out what happened compared to the original. So one, we have to remember what type of function this is. It's a U shape, so that's your x squared, your quadratic. And that our original parent function started at the origin 0, 0. Went right 1, up 1, left 1, up 1, and then right 2, up 4, and left 2, up 4. drawing in the original is not a necessary step, but it might help you visualize what happened. So if I'm comparing the red to the blue up here, or the original to the one that's already there, what happened? What changed? Shifted left. So that's a horizontal shift. Left 2 units, or 2. And because if the parent function just shifted left, it would line up with that one. There's nothing else that happened. So then we're going to use that to write our transformation. You may want to write this at the top so you have it. We need what the equation would look like. So I'm going to write it in numeric terms. Y equals A, then parentheses, x minus h squared plus k. Where A is shows your reflection and any stretches or compressions. Your H shows horizontal shifts, and your K shows vertical shifts. So we only have one transformation for this one, so it's going to go where H is. Since we don't have an A, you can either write it as 1 or leave it blank, either or. When you write what's on the inside, remember it's always opposite, because it moved to the left, so you're thinking negative, but if I put a negative in here, it would make it positive. So x plus 2 is what we would write. We don't have any vertical shifts, so we're not going to put a k. Questions on that before we move on? I know it from memory, so if you didn't know it, you could graph it in your calculator and find the points on the table. I would say try to memorize it.
Yeah, so for example, like since we know this is a parabola, we know the parent equation.
Parent function, yeah.
Parent function is x2, so if you just put that on the graph part, on the y equals, in the graphing calculator, it will show that origin.
One thing I forgot to mention that, going back to what we were talking about before, horizontal things are inside, that's why it was inside the parentheses. So just writing out all those little helpful tidbits might help you do these. Other questions on that one? We're going to jump around a bit. We're going to go to number 4. And again, you don't have to draw in the parent function. I'm going to, just so you see it. So if you want to start to memorize it, always start at the origin, move left and right 1 and go up 1, left and right 2 and go up 4. Or you could put x squared in your y equals and look at that table. So what changed here? It did move up by how many? But if it just moved up 1, it would be here. And it's been moved over. So we're missing one more transformation. Right? 3, I think that is. And then that would match. So we now have 2 transformations. Horizontal is still inside, and we did one like that, so we kind of know what that's going to look like. And vertical is outside. So we have our H and our K. We don't have A, so again, you can leave it as 1, leave it the same, leave it blank. How would we write that inside piece? And then on the outside, of course. So on the inside, it's always opposite of what you think it's supposed to be. Right is positive, but you're going to make it negative because of the formula. Squared, and then vertical shifts are always what they're supposed to be. So if it's up, positive. If it's down, minus. I can't speak to it. And that would be our equation. Questions on that one? And we'll pause there and continue. Before we move on, do we have any questions on 4? We're going to go to 5. 5 is now a V shape, so the parent function has changed. It's now absolute value instead of your quadratic. So that parent function, again, starts at 0, 0, and it just keeps going up 1, right 1, all the way, and up 1, left 1, all the way. So I plotted more points than the one that's drawn has, and that's okay, because the arrows mean it's going to keep going forever and ever in both directions anyway. And we'll talk about the transformations first, and then talk about the equation. So looking at the original compared to what's given, what happened?
Vertical shift up.
From this point to this point, did it shift up?
Down.
It shifted down. But if it just shifted down 1, it would be here. So what else happened? That's a vertical reflection. So the fact that it is now facing down instead of up is your reflection. And then what else? The horizontal shift. I'm going to write that here. I'm running out of space. So when we write that equation, it'll almost look like the quadratic one we had up here, but a little different. We talked about this before break. But it would be y equals a times the absolute value of x minus h plus k. So no parentheses, no square. But the a, the h, the k, those are all the same. So then if we're using that method, or that formula, and we know these 3 things happen, Your reflect is going to be where your A is. It's going to make it a negative A. We talked about the vertical shift and the horizontal shift before, so those will be similar. These will both be outside things, where this is the only inside thing, the horizontal shift. So we would start that off. Y equals, you can put -1 or just negative, either or, does not matter. Times your absolute value. How would we write horizontal shift left 2?
2.
What 2? It would be opposite. So it is negative, but when we put it in, it's going to be plus. And then vertical shift down 1. How would we write that part? -1 at the end. And that would be our equation. -1 times the absolute value of x plus 2, then -1 on the outside. What questions do we have on that one before we move on? Mm-hmm. We're going to do 6 next. Did you get the problem? Yeah, thank you. I'm going to draw in the parent function again, but you don't have to, but if it helps, keep doing it. This is again a v, so that's your absolute value of x. So what changed in this one? Did it move at all? Is it still facing the same direction? Vertical reflection, it did flip. What else changed? Okay. It is vertical compression because it got wider. But this here you're really just counting the slope. So you can count between any set of 2 points on either side. Here I'm going down 1 to the right 3 or up 1 to the left 3. So the negative in there is really because of the reflection. But it would be 1/3. There's one more. If it was just reflected and compressed, it would still be at the origin. Down 5. So here, all of our transformations are vertical, so everything can go on the outside, nothing on the inside. The reflect has to come first, and then any compressions or stretches. So how would we start this? A has to come first, but the reflection has to come before the A, and then we have our A value. What do we write next? -1/3 times the absolute value of just x. There's nothing inside except x. And then your vertical shift down 5 minus 5 at the end. Questions about that one? We're going to do a couple more than any of you guys want to see, do, or go over, and then you'll have time to practice. So we're going to start with number 7. I'm going to draw in our parent function. Again, you don't have to, but you can if you want to. It starts at the origin, right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. What changed? As the original, is the one that's graphed going in the same direction. Say it. Mm-hmm. So that's what flipped it.
Yeah.
What else happened?
Pushing up. 1, 2. Yeah.
Because if it just flipped, it would be at the same place, but it didn't move up 2. Then there's one more. Look at the original, look at the one that's given. What's different about them? Besides the 2 things we already have. What were you going to say?
Is it stretch?
It is a vertical stretch. You got narrow, so it is a vertical stretch. While stretches and compressions are really easy to find on your absolute value, you're really just counting slope. Here you kind of have to look at the distance between your vertex and the points given. So on the original, the distance between the vertex and one of the points was up 1, right 1. The distance here is 2, up or down 2, depending on how you start, and to the right 1. So that's how you can figure out that number. These again are all outside things because they're all vertical. I didn't write this, but this was our quadratic, our U shape. So how would we start to write this? Y equals we're using parentheses for the quadratic. But we need our A and our reflection. Negative was our vertical stretch factor. So -2. then you can either write this because we don't have horizontal with just x in the parentheses, or without the parentheses. Either or. And then vertical shift up 2. Oh, we read that part? Do we have any questions on that one? Last one. 8. So I'm going to again draw in our parent function, start at the origin, right and up 1, left and up 1, right 2 and up 4, left 2 and up 4. What changed from our original to the one that's given? Did it move left or right? Did it move up or down? Is it facing the same direction as the original?
Vertical stiff down.
So start from here, and then if this is your new vertex, it went up, but forth. What else? It did vertical reflect. Did a vertical reflect. It's upside down. It is a vertical compression, not by 2, but compressions are weird. With quadratics, because if you're counting that distance, you see 2 over 2 instead of 2 over 1. So it always has to be a fraction. So it's going to be 1/2. So the number was right. You just have to make it into a fraction. So 1/2. Anything else? Got that it moved up 4. We can move here. That it flipped upside down. That it's wider because of the compression. How do we get it to where it actually is? Horizontal shift. So all your vertical things are outside things. Your horizontal is inside. So we have something for everything, basically. And again, I did not put this, but this is our U shape, so that's our quadratic, our x squared. So then how would we write this equation? Y equals what? Start with any reflections or changes in A values. We are going to use the 1/2, and it was a reflection, so -1/2. Then parentheses, because it's x squared. How do we write that inside piece?
-3
Always opposite,
plus
+3,
plus
+4 on the outside. It's kind of smushed, but it does say that. So -1/2, then in parentheses, x plus 3, outside of parentheses, squared plus. What questions do we have on that one? Confusion that we want to get cleared up? Are there any others on this page that we skipped over that we want to see you go over, have questions about? If not, for the remainder of class, you could be working on a couple things. The Khan Academies from the 31st, so you can get those out the way. Send me or Ms. Larson emails saying that you did those. The one that's open today, that's due on Friday. And then any practice in here, there are a bunch of practice problems to help you write the equation from graphs in different ways. So you could be working on any of those things. Let us know if you need our help, if you want us to check over anything or work through something with you. Use this time wisely.